Okay, the last topic in this chapter is about the action potential. So the action potential occurs when a stimulus occurs in the neuron. Action potential. We've already had resting potential, and now this is another potential that you'll need to know. An action potential occurs when a stimulus occurs in the neuron. So something happens in the body that stimulates the neuron in some way. Under stimulation, the cell membrane will allow ions to move across. And so it allows this large influx of ions, and then that changes the membrane potential. Or you can think of this as the resting potential. There are two situations. We have graded potentials and action potentials. We'll mainly be concerned with the second of these. And then action potentials. Remember, the resting potential are usually at about minus 70 millivolts. That the inside of the cell membrane is slightly negative, about 70 millivolts. And an action potential, when the stimulus is strong enough so that it warrants, a really big response in the body, when the stimulus is strong enough, the membrane allows the passage of ions. So that the membrane potential goes from minus 70 millivolts to about plus 30. So this is our resting potential. When you apply some stimulus to the neuron, it causes an increase, a big increase of about 100 millivolts from minus 70 all the way up to plus 30. The ions are allowed to pass through the membrane, and a small region of the axon changes potential. This affects the adjacent region, causing a similar effect. And this current, and notice it's in parentheses because it's not really a current so much, but it has the same effect. This current moves parallel to the membrane along the axon. I've talked about this, so I just draw another picture. So if this is our axon, cell body over here, dendrites, or axon terminal over here, dendrites over here, our signal is moving in this direction. So usually it's at minus 70 millivolts, but I get all these ions that begin moving in, and it goes from minus 70 up to minus 70 up to 30 millivolts. So I get this big positive potential, and then it goes down again. But over here, I get a big positive potential, plus 30 millivolts, and then it goes down again. And then over here, it goes up, and then it goes down again, and it propagates down the entire length of the axon. The action potential occurs when the membrane potential this should be when it occurs, and the membrane potential exceeds the threshold potential. And this was on that graph in the previous page. You can see the threshold potential is about minus 50 millivolts. So when my membrane potential exceeds the minus 50, that's when this action potential kicks in, and the cell membrane allows this large influx of ions, and it causes the action potential to occur. And that action potential will propagate very, very quickly. However, when the stimulus is less, a graded potential occurs. And the graded potential propagates much more slowly along the axon. And it depends, what is the stimulus? Does the stimulus warrant a very quick response? If it does, then you get the action potential. If not, you get the graded potential. I have a video here from 2 Minute Neuroscience. It's really good, and I think that is the end of this chapter, so we'll pick up next with light.